Alright guys, so this is going to be talking about priority queues again. This will be adding to a priority queue. Now priority queues are usually implemented in a lot of different ways, but the main way is usually using heaps. So you might be asked to add to a heap as opposed to a priority queue, but it usually means about the same thing. A priority queue is going to be a binomial tree, which means it can have only at most 2 children. That'll be important for our topic below. Now we're also going to note that if it's a max priority queue, the maximum value will be the root. If it's a minimum priority queue, reversely, the minimum will be the root. So with that said, basically you're going to add an element using the breadth first search approach, and then you're going to sort of bubble the element up to its appropriate position, following just traditional binomial tree rules, where the parent has to be greater than the 2 children. So if we start here, we'll start and do it pretty we'll start easy to begin with. We've got an array. Note the subscripts on this. We've got 1 through 7 as subscripts. They aren't really all that relevant. Some people put them on, some people don't. It's just to point out the fact that it's an array implementation. Your final answer should also be in an array, which I will show later. So if we start, we build the priority queue. So we go through and we say 45, then 35, then 15, 31, 33, 12, and 11. Now all I'm doing is I'm marching down this row right here, hitting all of them, and I can't put more than 2 for each of the children, so you have to keep going and growing sort of level by level until you're done. So if we're going to add 74 to the following priority queue, a lot of people make the mistake of like trying to add it where it makes sense. So it's like, well, it shouldn't go at the 11 because it's, you know, greater than 11. So let's try and add it here or something like that. That's not where you add it. You add it and you start adding at the next available element. So you'd add it here because that's the next place you can put it, because all of these guys have their children full on this level. So if there was another one here and another guy here, the next place you'd add 74 would be right here. Okay? So now that we know that, we add 74, right like this. And then what we're going to do is we're going to say, is the parent greater than 74? No, it's not. Okay, so we're going to then swap this guy with this guy. So we swap 74 and 31. So 74 goes up, 31 goes down. We do it again. Is 74 bigger than 35? Turns out no, it's not, so we swap them again. Whoop. So 74 and 35. Lastly, obviously we can probably tell by this point that 74 will jump once more. And what was that number again? That was 45. Okay, so 45 is going to swap with 74. And then that's the end. So again, if you really wanted to do this, get full points, you're going to need to write out the final tree in a breadth first search approach, which will just mean level by level. So the final answer would be an array that looks like this. So let's have you guys do an example. See if you can figure out the result for adding 74 to the max priority queue. Pause the video, and we'll come back in a sec. Alright, so I'm back, and we're going to be taking 85, and 35, 15, 31, 33, and 12, and making a little binomial tree out of it. And then we add 74 in the next available slot. The next empty slot, you'll note, would be right here. So this is where we'd be entering something. So, since it's the next slot available, we simply add 74 right like this. We say, is 74 bigger than 15? Yes, it is, so we swap them. 74 goes up, 15 goes down. 85, is 85 bigger than 74? Yes, it is, so that means we're done. Now, technically, you'd write, again, an array, but I'm going to assume you know how to do that, and I'm not going to waste your time by filling that in. So let's do, let's see, just a couple more examples. Show the result of adding 27 to the following max priority queue. So we've got 40, 20, 30, 10, 15, 11, 8, 4, and 3. See, 20, 40, 20, 30, 10, 15, 11, 8, 4, and 3. Now it's important to make sure you add them all correctly or you're going to get the wrong answer, so just double checking the work real quick. So okay, we're going to add 27 in the next available position, so we can just look at it visually and see that we're going to need to add it as a 15's child, so we'll add it right here. Let me add the other marks so that way you can see everything a little easier. So we've got the 27, which will change places with the 15. 15 goes down, 27 goes up, and we can change the 27 again with the 20, and then we're done. Again, implement it as an array, and you should be all set. Last but not least, show the result of adding 47 to the following max priority queue. So if we build the queue, looks like this. (15, 10, and 13). So this is what the binomial tree looks like. If we add 47, the next available slot, we'd add it here. 47 and 39 would swap places. And 47 and 45 would swap places. And then we'd be done. Make sure you write out the array, and that would be the final answer. Let me write it out just to make sure you understand. We do it breadth first search, so we start here, and we go to the next bit going from left to right until we're done with all the levels. So 50, 40, 47, 30, 25, 45, 38, and let's move this all over here to make it a little easier. So we've got 38, then 20, then 15, then 10, 13, and 39. So that'd be the final answer, guys. Hope you guys enjoyed the tutorial. That's how to add to a max priority queue, and hopefully you understand now. Thanks for watching.